Hi, today we are doing Chapter 9, Molecular Geometry and Bonding Theories. The main focus in the chapter is to determine the shape of a molecule. In order to determine the shape of the molecule, we use VSEPR theory, which is VSEPR theory. What is VSEPR theory stand for? Valence, shell, electron pair repulsion theory. Repulsion theory. So, in what is the valence shell repulsion? Valence shell electron pair repulsion theory stays. It stays because electron repulsion. So they try to minimize their repulsion. So they try to be far apart as possible. When they become far apart as possible, they give characteristic shapes. So in terms of geometry of a molecule, there are two types of geometries you need to know. One is electron geometry and molecular geometry. So in terms of geometry, there are two types of geometries. Geometry of a molecule, electron geometry, molecular geometry. Let's see what is the difference in this electron geometry and molecular geometry. The difference in electron geometry and molecular geometry is, if you think about the difference in electron geometry and molecular geometry, in electron geometry, both geometries you need to identify electron domains around the central atom. So first step should be you need to know how to draw a correct Lewis structure. In chapter 8, we study how to identify a center atom, calculate valence electrons, and then distribute these valence electrons around the terminal atoms. And then you look at the octet in the center atom. If the center atom does not have 8 electrons, you can give double bonds and triple bonds. So in that way, once you draw Lewis structure, you count how many electron domains around the central atom. If you draw your Lewis structure correctly, then you can calculate the electron domains around the central atom. Depending on the number of electron domains around the central atom, you can easily predict electron geometry. There are mainly 5 electron geometries. 5 electron geometries are, let me look at the PowerPoint. Mainly linear, trigonal planar, linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. So, if you have 2 electron groups around the central atom, if you can see this structure, I have 2 electron groups around the central atom. This is a center atom, 1, 2. 2 electron groups around the central atom. The geometry is linear, bond angle 180. So this is the linear electron geometry. It is linear electron geometry. Okay, so we did linear electron geometry. So this is the linear electron geometry when you have 2 electron groups around the central atom. And this is linear. And then if you think about 3 electron groups around the central atom, this is 3 electron groups. This is a center atom, 1, 2, 3 electron groups around the central atom. It's like a planar, trigonal planar geometry. Bond angle is 120, trigonal planar. Again, 4 electron groups around the central atom. Tetrahedral shape is like a tetrahedral, 1, 2, 3, 4. Bond angle is 109.4. This is the tetrahedral geometry. And we have linear, trigonal planar, tetrahedral. And then 5 electron groups around the central atom. 5 electron groups around the central atom is trigonal bipyramidal. You can see center atom, 1, 2, 3, 4, 5. So this 3 bonds, we call these 3 bonds in a plane called equatorial bonds, up and down axial positions, 3 equatorial bonds up and down axial, 3 equatorial bonds we call the equatorial bond, and then up and down. So this is the trigonal bipyramidal geometry. Bond angle in equatorial bonds is 120. Bond angle between axial and equatorial is 90 degrees. So this is the trigonal bipyramidal. It's like 3 pyramids on the top of each other. See, this side is one pyramid, downside is another pyramid. So this is a trigonal bipyramidal geometry, 5 electron groups around the central atom. And I have the last electron geometry, which is octahedral. Octahedral is 6 electron groups around the central atom, which is octahedral. Bond angle is 90 degrees. So these are the electron geometries. Now you know what is electron geometries. 5 electron geometries: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Again, linear, trigonal planar, tetrahedral, 4 electron groups, 5 electron groups. It is trigonal bipyramidal, 6 electron groups, octahedral. So these are the 5 electron geometries. In electron geometry, you just count electron domains around the central atom. Electron domains, it can be a lone pair, it can be a bonding pair, double bond or triple bond. Just identify the number of electron domains. Now we look at the molecular geometry. What is the molecular geometry? What is the difference between electron geometry and molecular geometry? The difference in electron geometry and molecular geometry is, in molecular geometry also you draw correct Lewis structure, you count the number of valence electron domains around the central atom, but once you count it, you differentiate them as lone pairs and bonding pairs. If you don't have any lone pairs in your compound, electron geometry and molecular geometry is same. But when you have lone pairs in your compound around the central atom, at that time molecular geometry and electron geometry is different. So let's look at each structure and see what are the molecular geometry. So depending on the number of lone pairs around the central atom, it is different molecular geometries. But always electron geometry is same, which is you count the number of electron domains. So let's look at the molecular geometries. So let's look at first structure, which is linear shape. So in the linear shape, you have always 2 electron groups. When you have 2 electron groups around the central atom, electron geometry is linear, and then there's no molecular geometry because it cannot be one bonding and one lone pair, right? So this is linear. So let's start from the trigonal planar geometry. Trigonal planar means you have 3 electron groups around the central atom. 3 electron groups around the central atom is trigonal planar. Let's see what if you have one lone pair. One lone pair, it is bent. 3 electron groups around the central atom. One lone pair always take a bigger space. So that's why lone pairs are more negative charges and take more bigger space. So let's add a lone pair and show you how it. So now when you have the lone pair, it take much bigger space. So then these 2 bonds tend to, these 2 electrons, there's no bond now, just a big atom here. And then these 2 bonds tend to go closer. At that time, 3 electron groups around the central atom, 2 lone pair, 1 lone pair, 2 bonding pairs, it's bent. And now we are moving to our 4 electron group structure. 4 electron groups, electron geometry, always tetrahedral. So 4 electron groups, so this is tetrahedral. Electron geometry. And what about if you have 1 lone pair? When you have 1 lone pair, it is trigonal pyramidal. It's like a triangle and a pyramidal shape, trigonal pyramidal. So 4 electron groups, 1 lone pair, trigonal pyramidal. Everything is in your PowerPoint. You can look at the PowerPoint as well. And then, so this is the 4 electron groups, 1 lone pair. It is the trigonal pyramidal. And then 4 electron groups, 2 lone pairs, it's bent. 4 electron groups, 2 lone pairs. It's a bent electron geometry. Now I'm going to, if you think about tetrahedral structure, tetrahedral is always electron geometry, 2 molecular geometries, which is trigonal, pyramidal and bent. Now I'm showing you 5 electron groups around the central atom. Always keep in mind, in the 5 electron groups, I told you there are 2 types of bonding, right? Axial and equatorial is on the plane. See, it's in the plane, and up and down is axial. Always lone pair comes to the equatorial position. So if you have one lone pair, right? What kind of shape is like that? For me, I feel like a seesaw, right? It's a seesaw. Seesaw. So 5 electron groups around the central atom, 1 lone pair, it's seesaw. So I told you always lone pair come to the equatorial position. 2 lone pairs, it's T shape. It's T. And 3 lone pairs, it is linear. That is the 5 electron groups around the central atom. So this is the trigonal bipyramidal electron geometry. There are 4 distinct molecules. Trigonal bipyramidal, if you have all bonding, right? All bonding, it's trigonal bipyramidal. And then 1 lone pair, seesaw, 2 lone pairs, T-shaped, 3 lone pairs, linear, 3 lone pairs, linear. And then we are moving to our last electron geometry, which is octahedral. Octahedral geometry. And then in octahedral, all 6 bonds are same. 1 lone pair, what type of shape? It's the bottom is like a square, pyramidal. And when you have 2 lone pairs, square planar. So these are the shapes in octahedral geometry. So with this one, I hope you understand how to predict the shape of the molecule. And also, you need to know there are basically 5 electron geometries: linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. And then each geometry, depending on whether they have lone pairs, they have different molecular geometries as well. Thank you very much.